Hello everybody. I guess I'm streaming. I don't know anymore. I feel old. Welcome. It's 8 o'clock, which means episode 3 of Zero to Zero Day. I wish I had some good intro. I you know, some people have some fancy intros or something, but we just get down to business. Episode 3 kind of equates to hour 3 of looking at NVIDIA GPUs. First episode, we just kind of talked about what I might be looking at. Last week, we looked at drivers specifically and how you communicate with drivers from userland using the iOctal interfaces. And, you know, I mentioned last time that's not what I'm going to look at, but I hope it was some decent information, and I hope even more that somebody was inspired to maybe go out there and start reversing it or looking at it or fuzzing it or whatever. There could be bugs. But I want to kind of get on. I kind of want to get on with what interests me, and that's really going after the actual GPU and how we might be able to take advantage of it. I'll say, let's see. I did end, I think, with showing the metal kit. Let me see. Pull up. Now just all my links are all fucked up. Okay. Showing metal kit, and I wish I had a lot of time to actually play with this and audit how VMware is drivers implemented, not only from the host side or the guest side, but on the host side. I imagine that there's a lot that you could do from having raw access to the PCI device inside of a VM. And what MetalKit does that's really cool is allows you to basically get right down to the lowest level that the VM can access before it has to be VM exited out to the host processor. So if I had extra time, I would take this metal kit and this project here. I think it's the same thing. Maybe it's not the same thing, but they use metal kit and they have some other stuff. But anyways, I would probably write some kind of fuzzer for this because it allows you to run it very fast. It allows you to get raw access to the driver, or you don't even need a driver in Windows. It gets raw access to however it's implemented inside of the virtual machine. I'm sorry, the hypervisor. And it's got a lot of these definitions. So maybe just 1 second we'll spend looking at this. And I'll say again, episode 3, but really 3 hours. I maybe spent 30 minutes beforehand looking at some of this stuff, but I just don't have any time these days to, you know, to reverse for 12 hours or to audit for 12 hours. So we are going to try to move on to actually picking a target today and figuring out what that means. So I did notice this. If anybody's watching, please audit this. I know that I think some people have talked about this, but this is like a backdoor hypervisor codes, and I think you use the in and the out instructions, x86 instructions, with loaded register with some of this stuff, and you can talk to a backdoor channel. They say backdoor. Don't think it's like a malicious backdoor, but it's definitely not something that you would probably use in a production environment, and maybe people don't know it exists, but you have to kind of do this port knocking on it, I think. So you have to use this magic and then the command. I could be misremembering this, but I'm pretty sure that I saw at one time in the past from the guest you can do a specific sequence and run these commands. So someone please look at it, or at least if you're in the Discord channel, if somebody out there has done work on this, I'd love to just read what they found. I'm sure I could Google it, but this is really cool. And so I'll drop this into the Discord channel. But another good maybe target. Anything that says backdoor is fun, especially as a reverser. Again, I don't think it's not a malicious backdoor, but anytime that you see anytime you see code that isn't necessarily for what you would think the vendor is trying to do, for instance, NVIDIA or VMware. So VMware has a hypervisor, and they have a 3D access, 3D acceleration. So there's obviously going to be a normal place that they kind of talk in between in the hypervisor. But to see that there's this kind of weird interface that is documented or not documented, and it's called backdoor, and it looks like it's a little bit janky, and they want to keep it hidden, but those are always kind of fun. You can maybe find something there. But you really stray off the beaten path is where you'll find the most, I don't know, potential. I think I've said it before. Some people audit differently or pick their targets differently. Some people just go straight for the main thing. I think it's fun to do reversing as like an exploratory thing, and then finding bugs is kind of a part of that too. And if it's not audited or people haven't been looking at it, then it's usually a little bit of an easier target or more fun to get into. So check this out. And write it in Metal Kit so that you can have a cool thing to watch as it fuzzes. I think it was Metal Kit. Let me see. So this is a video BIOS. I think maybe this is, no, that's the regular guest BIOS. Well, where was I where it had the 3D bunny picture? Anyways, I won't sit here and just mumble out loud about this. Fuzz it, find something fun, get back at me. I'll also give a shout out. There was a bug, it's now been 10 years, called Cloudburst. Cloudbreak from Kostya Korchinski, published by Immunity a long time ago. Yeah. And this was actually a VM escape. I remember when this came out. If you don't know Kostya's work, he's in my probably top 5 vulnerability research and exploit developers, and he's been around for a long time. Anytime he comes out with work, it's very, very high quality. So I did remember this, and he's kind of digging into that same thing that I was talking about. I didn't realize this until I started searching. I just kind of completely forgot about it. But I remember when this came out, this was really, really cool. And of course, Immunity wrote Kostya and that team wrote a good actual breakout. So there's some demo stuff. So again, I don't think anybody has picked up on this research and really explored this again. I'd really be interested in anything that's changed, potentially some new bugs, but this was called Cloudburst, and really fantastic work. I'll post this in Discord as well. So he's using the Direct3D API too, so there may be overlap with what Google did in the Direct3D kernel and whatnot. I'll probably go back and look through this a little more detail, just in case there's some nuggets of wisdom for specifically what I want to look at. I don't think this is using the in and out. Oh yeah, it could be. So these could be the backdoor, or some of these commands are in there. You can also look at the project and map a lot of this. I think it was in header files for that previous project, the SVGA, VMware SVGA project. So I think these were, and here I think Kosha gets at exactly what I was talking about. The way the SVGA FIFO works is undocumented. It's only supposed to be used by video drivers. Great place to look. If it's undocumented, it means they want it to stay private, and poking around there is usually worth it. There's some memory mapped I/O. I just wanted to see if he had. Okay. Anyways, check this out. Cloudburst. It's 10 years old now, but I'm sure this wasn't the end of the bugs in VMware. In fact, I think I think they published. I think there were multiple vulnerabilities. I don't remember how many. Let's see if this link works. Oh, that's a shame. That link doesn't work. There's a movie of it, which is neat. Well, I mean, neat as, you know, I wish it was like a hacker movie where, you know, shit was jumping out and catching on fire, but really it just breaks out, pops calc. But the amount of work that, I'm always interested, the amount of work that goes into popping calc, it's almost ironic, or I don't know. It's just, it's strange we use such a simple payload to demonstrate such a terribly complex problem, or maybe months of work. We should find something that kind of expresses ourselves a little better. But I still think it's funny that all this work, you're in a guest, unprivileged or privileged, I don't know, but you break out, you exploit the host, and you pop calc. So maybe we shouldn't change, because now it's just straight tradition. Okay. Lots to do, lots to do. Okay, so what I'm interested in are a few things. I want to, if I'm going to put this effort in, I'm going to go for the GPU. I think it's got the most attack surface, least explored, and the most possibility for exploit. However, it is very the more that I read about it, the more complicated I realize it is. And I'm not sure if one person could work on this for an hour a week and get anywhere. We're gonna try, but to me this is new. I haven't seen much research in this area, so it's fun. We can learn about some things we might not have known, and I'll give it my best shot. But we also might want to think about doing this every 2 weeks or every month, just to give myself a little more prep time, and I can write code and whatnot. But I'll just kind of, if anybody has an opinion, that'll be, I'm all ears. So there's two things. There's OpenCL and CUDA. OpenCL is the like an open compute language, I think is what the L stands for. And CUDA is NVIDIA's compute API and library and everything. So they're kind of the same. At least they're the same in what they hope to accomplish. And that's that you can write highly scalable software, upload it to your GPU runs it, and you mine Bitcoins or whatever you do. You build machine learning models. That's one target that I'm interested in. And OpenCL, I think, is open source. So that would be possibly the compiler, the build tools. That's not necessarily it's not open on the actual GPU core. So it would be just an interface, like an open interface to executing parallel code on the GPU itself. CUDA is proprietary, so you know, it's probably just as documented, but less friendly to other vendors. Whereas OpenCL is what you do on AMD and other video processors, I guess. So we can maybe decide. I might just do CUDA because it's proprietary, and I know that NVIDIA and CUDA are basically ubiquitous in machine learning and in graphics rendering and all those things. So that might be where I go, but that's one option that we have is the compute languages. The compute side has a counterpart in graphics that I know you're probably familiar with. That's the OpenGL. I think DirectX is the same thing, but that's the graphics counterpart. So if you have a open compute or a compute, then you might have a 3D graphics library, and that's what OpenGL and DirectX and whatnot are. Now, for the graphics versions, those are much more host and GPU connected. So you would have a graphics, your main graphics code would be doing things on the host, talking to different devices, managing tasks, all this kind of stuff that they need to do, drawing, etc. Your GPU is doing more intensive applications behind the scenes, like running shaders and whatever else that may entail. So I think in that area there's a lot more. I think there's a lot more that runs on the host, which we're not concerned with. There'll be stuff that is translating in the kernel, and then there'll be shaders or some type of file format or whatever it is that's compiled and uploaded to the GPU, and then that's ran asynchronously while the host processes what's coming out of that. So that's a much bigger thing, although we might be able to pare that down to just shaders. So a shader, if you don't know, is a way to like raster 3D graphics or apply transformations to frame buffers. So in a game, a shader is what makes it look like water, or a shader is what makes fog, or a shader does physics simulations, and that needs to run on the GPU because it's so intensive, compute intensive. So and the good thing about shaders, and let me pull up, I think GLSL shader language. So the OpenGL has one, and then maybe HL. This might be this is the proprietary Microsoft Direct 3D one. So the interesting thing about shaders is they're not necessarily, they're not straightforward. They're not like in CUDA and OpenCL, it's basically just C, you compile it, and then you upload it and run it. And I think it's a lot more self-contained, which has its benefits. The shaders are less general purpose, and so I think there may be more things to do with fuzzing the memory, the inputs, the outputs. You can run multiple shaders on your GPU, so how do they talk? What's shared memory look like? I think there's more of that, which could be a downside because of complexity, but could be, complexity is not bad. Complexity is just harder and takes more time, and oftentimes the complexity is what gives us the good bugs. So let's just look at GLSL and just show you the language real quick. So when they say they need the API, there's all these calls to compile your shaders and then upload them. There is a actual instruction set. Oh, here's another one. So there's low-level languages and high-level languages. We probably want to do low-level languages because we want to control more. In a second, I'll show you all this Chronos group. just wanted to get a. I just wanted to demonstrate a little bit about how these shaders would be written. This is a really low level one, so it looks very similar to any kind of instruction set, except with shaders and really anything with graphics. It's more vector or matrix multiplication, and so they'll have instructions like dot product or cross product and all that kind of things to quickly get 3D vector information into a raster 2D image. But you can see that this is different and maybe good or bad. I don't know. We'll see. So I think it kind of comes down to OpenGL with the shader portion of OpenGL or OpenCL, and what's executing on the GPUs. I think enough people have done some work onto the kernel driver side of it. That's why we skipped it last week, and I really want to actually crash the card itself and see what happens, and then not to take on too much, but writing an exploit on the actual GPU cores would be really fun if it's if I could do it, of course. So this Chronos group, and I'll show you how this all kind of ties back to NVIDIA in a second. This Chrono group builds the standards. They also build the libraries. So they are kind of the one-stop shop for looking at OpenGL, OpenCL, all these different things that you can look at that are 3D related, and they're open. So they define the standard on the APIs, how you use them, and then they also usually build an SDK or some way to hop right in and use it in C or C++. So it's just they've just defined libraries, and then they define a lot of the other specs. I think if you go and you're in NVIDIA and you want to support OpenCL or OpenGL, then you would get their document. You'd get their, I don't know if they have something else available for vendors or OEMs, but certainly the APIs are all out there. So this could help us when we go to write an OpenCL program and maybe a fuzzer or test it or debug. But just so you know, Chronos Group is publishing a lot of this. Oh shit. So stuff like this is what I want. I want to look at how shared virtual memory or shared memory happens with compute. Remember that we're not in a world where this is just, you would exploit this from a local host on some computer out there or whatever. In the cloud, it's starting to put all these GPUs together. You've got multiple hosts using multi-tenant on a single GPU. You got GPU sharing. We're seeing a lot of this kind of stuff. So you may have a situation where we break down these boundaries where if you upload an OpenCL kernel to a card, they never thought that another process might actually be doing the same thing or may have some kind of multiple people or intentions on the same card. So keep that in mind. There could be some new types of vulnerabilities that come out just based off of strapping these GPUs in the cloud, like shared memory or whatever. Okay, how this all maps back. If you've ever, I wrote this tool a while ago. It's called Hackers Grep. It's on my GitHub, but basically I use it in the way that I'm using it now. So it's Python. It's dreadfully slow, but it allows you to kind of do target selection. So if you find something while you're reversing, you can quickly come and find out who else uses it. Here's an example that I thought would tie into what we have been doing. So in last episode, we looked at the NV admin device, and I thought, we saw that in the kernel, and we knew that the kernel was going to be the host of that and handle the ioctls to the driver. but I didn't necessarily know who could talk to it, and I certainly didn't know what all the NVAdmin device might do. So using something like HackerGrep, or you can do this any way you want. You know, it's with HackerGrep, you can also grep through symbols. Doesn't make sense here, but for Microsoft, you could ask it. Like if you found a class in one DLL and you knew there was a bug, you could use HackerGrep to search the actual symbols for something similar. I've used it before if I wanted to see like download file, like every DLL in System 32 that has download file mentioned in the symbols for its class or its method, and you'll see some pretty cool stuff. Doesn't do anything besides that, but what is relevant is something like this. You have our device, so we know there's a kernel driver, and we know that at some point the kernel is going to have to, no matter what we do here, userland's going to have to tell the kernel to do something for the GPU. So there is going to be a connection. Maybe it's the NVAdmin device, but by doing it this way, you can see that these DLLs might have ioctls that are interesting to us, not from a VR perspective, but from if we want to load code or we want to break some kind of isolation or expectations, then maybe in this case, if we look at CUDA, maybe we just reverse out all the ioctls in CUDA.dll that talk to NVAdmin device. And perhaps that tells us that, you know, there's the documented stuff that we know about CUDA, but there's also some things that were not documented that through reverse engineering we're now able to touch. So the two ones that we are concerned with, I didn't look at the GL stuff. So the GL, after reading Google's post on the DDI escape, I think that in the DirectX world, you wouldn't do it this way. I think you would do it through the DirectX kernel, and the DirectX kernel will call into the driver. It may still use NVAdmin device, and I think that's what Google showed in their docs. But it wouldn't be just a direct create file and send to. It would be that that DirectX library in userland that calls DDI escape in the DXG kernel.sys, which then probably, you know, knows which vendor's driver to look up and to call. So that could be an indicator that maybe we should look at CUDA or OpenCL. So before I talk anymore, let's actually just disassemble nvcuda.dll and see what's in there. I haven't released my get IDA thing yet because I like it. The only problem is, and I realized it with this, y'all won't have the same version of the NVIDIA drivers that I have. You could go download it. So my base DLL that the base IDB is using isn't going to work. So I'm trying to figure out, and if anybody has opinions, that would be cool. What is the best way to maybe swap DLLs and sys files? I wrote it so that I don't have to check in to get 167 meg IDB. But I might check in the 16 meg one. I think that's still probably too big, and I don't really like binary files in Git personally. So what my thing will do, it'll take a diff of what you've done and check in the IDB diff into Git, and so you can manage your diffs, and just there's a Git command. You just do Git IDA apply, and it'll apply your diffs to your IDB. So anyways, I'll try to find time to actually release it, and if people like it, whatever. If they don't, I don't really care. Let's check out NVCUDA. I'm on the right here, and you know, all of our NVIDIA stuff's nicely grouped. So I'll grab this. While this disassembling, we'll actually look at something else, which I think is interesting. So these right here are decoder plugins. And Microsoft had a lot of these bugs back in the day where they had a decoder that is a plugin, and in using a 4cc inside of some kind of container format like MP4 or whatever. It's been almost 10 years since I've looked at this. You can set a 4cc that tells you that something was encoded with a type of algorithm or whatever compression. And Microsoft had a lot of bugs where you could set some really old encoding. It was passed off to one of these decoding DLLs, and there were just heap overflows galore. I didn't notice this until today, but there's actually a NVIDIA MJPEG decoder, and I think there was a CUDA one as well. So what's interesting about this is I don't remember, obviously don't know all the bugs that come out, but I don't remember people looking at vendor-specific decode formats inside of that approach. So there was like, maybe it was an encoder. So here's the encoder version of it. Here's the decoder version of it. And while we're letting IDA do its thing, we'll look at Regedit real quick, because I'll show you what it does. You know, one of the goals of starting the Discord server was if anybody wants to kind of hop on and pick an area and discuss it and look at it, you know, I'm giving out a lot of things that I think are going to be fruitful for vulnerabilities. I just don't have the time to do them all. But let me just show you enough to get started. So I remember, I forgot how these are registered, but they're basically you supply a 4cc. This is a COM object, and I forgot which DLL it is in Windows, but basically in Edge or in another thing that can play videos, it'll look up that file type, look up the 4cc, match the 4cc to the decoder, and then instantiate this COM and hand off to it. So you can fuzz them very, very easily. And they've had tons of bugs in them. So let's just see if I can find the 4cc code. If you don't know what a 4cc, it's just a 4-byte ASCII identifier. AVI space, I think, was one. You know, there's hundreds of them, and for whatever reason, I can only remember one that might not even be right. But if you've ever seen magic numbers like that are D-word size, you call them. I guess 4cc just meant kind of like maybe at some point it was just some padding or whatever. But in IDA, they're almost always a constant, kind of like we saw with ioctls. If you look at a decoder library, you'll often see this where there'll be some magic numbers, and they just look like they're random constants, and they convert to ASCII. Those are typically your 4ccs, and they're actually a really good thing to find because it means that you as a user have control over that code path. We're doing this while IDA's okay. So IDA's done. I'll give this a second. If anybody wants to track this down, it's checking your registry for anything that looks like this. And I could be completely wrong. This might not even be the right thing, but I feel like this is how everybody does it. In MFT, I'm not sure. Anyways, check it out. Here's an encoder. There's another one that I think is really interesting, this JIT compiler. I don't know if this is coming through on the stream, but I'm just looking at the description and some of the stuff. All right. I'm going to search 2 more times. Promise. Let's check Discord, see if anybody's... Nope. Honestly, I don't even really check the stream. I don't know if anybody even watches this, but I think some people do. I'm going to do one more thing. Let's get past all the column objects, although it may be right in here. this also can map. All right, I'll quit. It's in here somewhere. This also sometimes can map to your MIME handler inside your browser. If it's like a .avi or .wave or whatever, sometimes it'll load a DLL, but I haven't seen that in a while since everybody kind of uses the same stuff. All right, so we're at NV-CUDA over here. Sorry to sidetrack, but IDA takes a while to load sometimes, so I gotta have something to talk about. What I'd want to see here is whatever exports it may have. And what this is telling me is it's just a library. And just because of the number of exports, which I pretty much assumed. And I want to just get a sense of how you may program this thing. I can go look at the docs and I'll pull some of those up. But sometimes I like to just kind of not only look at this, but look at how it may connect to the kernel, which we'll look at the imports in a second. So we will do, let's see how they implement, I think it's called CUDA memcopy. I'm not looking for bugs. I'm looking just at getting my feet wet. I think it's called CUDA memcopy or CU memcopy. So let's see if that's exported. Yeah, so here's memset. So we can see we got like a mapping here, almost directly maps. So all these that we saw before. Sorry, I don't know why that beep is still on. Copy. What? Come on. Top. Yeah, okay, here, see? It just mapped. So we know this is, if we program, the reason I'm doing this, it's obvious, I think, to everybody, but the reason I'm doing this, because I also want to know where I have user input. And the better I can match up the documentation to the binary, I can read in here, I could be interested, I can come over here, I can reverse it, I can go back and forth, and I found, at least for me personally, I get a much better understanding of not only you know, how it may be implemented, but how it actually gets to the GPU. So, you know, memcopy, we all know that's abused. I can now say, all right, let's, like, how does it actually know what to do here? And this could be just the you know, I don't know anything about how you write CUDA, so this could be some kind of implementation detail that I'm just not aware of. Like, your library links against this one, and that's all that the NVIDIA CUDA compiler does. It just links against this. I don't know. I thought maybe it would do something cool. But as we talked before, I remember this might be an ioctl, might not be. But since we do know we want to be here, it's not ASCII. Right? Shut up. It's not ASCII. For naming, I haven't talked about this since we haven't really done a lot of reversing, but for naming, I have written some C, so I kind of have a naming convention there. I try to reuse it when I can in IDA. The thing that I don't like to do when naming IDA, I don't like to get rid of any type information, and I don't like to get rid of any stacked positional information. So I think it's important to be consistent, but I'm the least consistent person about some of this, even though I preach it. You know, whatever. And just quickly to get a sense of what we may be dealing with, this doesn't change very much. So you can see it's the same value, and they all, let's see, I'll make this a little bit bigger. You know, so maybe it's not, maybe it is, I don't know. Anyways, you build it up. You don't know right off the bat ever. You just build it up. Actually, one second. Let me see who writes to it. So this is setting a value. Just getting a module handle. Does it make sense? Oh, this is actually, it's actually this function. So that constant, this drives me crazy. I've actually seen this in some of these NVIDIA things. This is a trampoline, and there just has to be something overriding this trampoline, because this is completely unnecessary. So maybe there's an implementation detail that we should figure out and try to figure out how to clean it up in IDA. But it drives me crazy because I can't really like look at this. I'd have to like, every time I have to do. Okay. So that's where we kind of set this flag. Let's see where we set it again. It could be an IOC. I don't know. It could be an IOC. It could go down that whole path and finally hit that. We'll look at that side in a second. This just clears it out. So this is some kind of initialization. You come into this function, sets it to 0, bails out. So maybe that's actually a bad case where it didn't initialize. Otherwise, it has this value. And where would it put? Here's another tip. If you want to just quickly find this information instead of clicking around like me, just switch your sorting to right. All right, so here we go. It's some kind of state. Could be an ioctal, but it's also could be some kind of state. So we're back here. This is our mem copy. We're back here. I am going graph just because I want to see what this may do quickly. My failure case is on the left, I bet. There's probably some debugging. There's a structure passed on the stack. If I go too fast, it's because I'm not ending in what I really want to see. I really want to see like what this thing does, like what it actually does on the GPU. So if it's a leaf function, which means it doesn't have a branch, then I'm not gonna fool with it too much. I feel like we're missing something though, because all these jumps. Because if this is a trampoline, then what we're seeing here could be like an unimplemented type problem, and in a debugger we would actually see this overwritten. This is interesting. So there's a function pointer. There's a function pointer here. RDX. Okay. So we've got class or pointer. array. So some different CUDA debug error, which, you know, it's not in the actual GPU, but maybe something we explore later. I'm not going to be able to just reverse this in 2 minutes because this is some kind of class, and it's going to take me a little bit to reverse that. The way I would do it is probably find the constructor and see if I can work out the base classes from the constructor and any derived classes. But that's a really long process. If anybody has any new way to do it, that would be sweet. But I bet that's the function we want. Unfortunately, it's not going to be easy, as you would expect something like this to not be easy. Oh, this is driving me crazy. All right, what is this? That's ASCII. No, it's not. Is it? Nope. Nope, don't do that. I thought I could hit. Usually it'll show me. H will go hex. B binary. Is it C? A? That was A. C, A, K. Nope, that made a function. Anyways, if it was ASCII, usually it'll at least have the ASCII version here to switch it to. So maybe it's just not right ASCII. No, in fact, of course it's not. There's like an 83 in here. Oh, that could be right. Anyways, sorry, this is what I do. I talk to myself a lot when I'm reversing. Where do you go? So this is better without graph view. These are just all the locations. And it loves this. It's faster that way. I think it's a caching. I think with your instruction cache, it's much more efficient to keep all your offsets here versus try to compute something or whatever. So sometimes you'll see that. Sometimes you'll also see like function pointers and stuff interspersed too. But anyways, this doesn't say anything to me. I thought we were maybe onto something, but it's just loading different values from the structure passed in. Oh, see, I have to get rid of this. Okay. Well, I'm not going to get as far as I wanted, partly because I have to do this stupid jump multiple times. But this is a branch down from the mem copy. You know, it's like you can't spend too much time. Sometimes I'll get in a rut. Well, I'll just do this. I'm also it's kind of busy work. If you get too caught up in it, or you're just following stuff, I'm not really understanding anything. Obviously, I'm almost just, I don't know. You can get in a caught where you're just doing this too much and it's not doing anything for you. So just be aware that if you find yourself doing what I'm doing now for like an hour, then take a step back and formulate a plan. All right. So let's look at, we'll go back up to the mem copy. This is the 2D one. I'm not sure. So in IDA free, I don't. Oh, they do have proximity browser. Cool. If you've not seen proximity browser before, then it's pretty neat. I feel like it was kind of lifted from not VX class, but Halvar's Bin Navi. I feel like it was kind of lifted a little bit from Bin Navi. It's probably won't work very well because we have all those jumps, but we'll just check it out. You know, it's like GraphView on steroids. But it should get us where it's powerful is like if we what I'm trying to find really is a call to a device I/O control or something like that, or something hardware focused or kernel focused. So it's really nice if you have an import and you're just trying to get to a certain location. You can just do this and not have to jump around like I was jumping around. See, so in this case we're at an import, and I bet you could, yeah, collapse all. Can I? Mouse hacking. Again, I'm kind of an obsessive person about something, so I do this for far too long, but I always think it's just going to be that next click and I'll see device I/O control or something. Anyways, that's proximity view. If you have never seen it. And back to GraphView. So like we did before, so what I've learned in the last 15-20 minutes is just that we've got our library here. I am going to look at this imports again because I want to see if there's that if there's anything that off the top of my head, or just seeing this tells me that it goes down to the kernel. For y'all that don't know, it is hot as shit in Texas. My little office here is like steamy. Don't forget to look at your get proc addresses and your load libraries too, if you don't find what you're looking for. Or create file. You know, we know that we have to do a create file to actually send it by octals. Hey, look at this. So that's cool. So there's actually a, I guess an ELF file that gets passed to this, and it calls into another library that I did see in our directory, and it was called NVFAT binary loader. Very interesting. I wonder if when you compile it, maybe we're not seeing it, but maybe when you compile CUDA, it separates the API, the compiled API side of it, and how you talk to that API, and then whatever's passed down to the GPU, maybe it actually has already compiled that, and it's packaged as an ELF, and all this thing does is send a big blob down to your driver, which wouldn't be a bad way to do it, because you're going to have to send some kind of blob to your GPU anyways. So that's a pretty good hint, or pretty good kind of breadcrumb. So we know that there's, I think the only, so there is this, I don't have my tools on here, or I would do a, merge those graphs down, so it would go from CU memcopy and device I/O control, and just look at the control flow graph and see if they overlap. It works sometimes, but it can be misleading because if it's a function pointer, you won't see it. Let's just let's see if this is in a function pointer anyways. Something is up. Something is up. Ah, it's R. So that one wasn't ASCII, it's R. Oh, how we forget. Let's just do this. We know this gets to our thing, and if it's ASCII all the way down, what is it? Is it ELF? Is it a magic? Is it special? Don't know. If anybody has ever done this professionally for a really long time, I'd love to hear if you were like me and after you go for a long time, you just start talking to yourself late at night. I don't have time to do it anymore, but I can remember many, many long nights talking to Ida as if she was a real person. Okay, so we got a D. Let's see. No. It's not jumping out at me what it is, but it's something. I'd have to spend a little more time. It is doing, oh, even more fun. Let's do real business here. I'm just curious what this is. Maybe it might not jump out. Yeah, interesting. So, could be not ASCII at all and just simply the way that it shook out. If anybody off the top of their head was able to kind of figure that out, let me know. Okay, so a few things we can reverse that would maybe be worthwhile. That's this path I'm looking at now. I might do that before next time. I don't think this will end up going anywhere that we're going to just be able to like connect the two very easily. This could really, when you're going to reverse something like that, you need to go. You kind of need to start from something concrete. And I think that's an exception record. So we could be just missing a function pointer somewhere. I don't know. Sometimes debuggers are good for this. Since we can write a program for this and compile it and upload it, we do have an API. I could trace it in a debugger, and I might, just to save time. I'm not really. I don't really need to understand a lot of this now unless I found something that was completely foreign or interesting. But I'm just looking for something concrete. Okay. Here's your device I/O control. There's only one. Is that the only cross-reference? No. All right. So you also might want to go. This looks pretty easy to reverse. That I/O control. But I'll use this one as an example. So I bet this is building a. You remember last time we talked about an in-memory and out-memory buffers? I bet this is building the in-memory buffer. So on the kernel side, we could certainly check if packets come in to that device with that ioctl, with this ioctl. Where'd it go? Where the fuck did it go? Oh, it's right here. We could just kind of look in the kernel. Maybe set a breakpoint there. You know, whatever, however you want to get to it. And this could be the start of the packet. So from the kernel side, we could kind of connect the dots, and that's really what I'm trying to do right now is connect the dots. So some more info. There are 87 of these. 87, and I don't know. So this is kind of the same pattern. All right. It's been an hour. We're dancing around. I don't really want to do that, but I do like this CUDA interface. So I think what I'll do, I think we'll look at CUDA first. I might not look at it. This will probably be the first target that we look at. How we build a CUDA program, how we upload it, how it may be when you do compile it, how it's broken out. If we see that FAT file, we may look at the FAT file, but we also may I may just do some debugging to try to get closer to stuff that we want to spend time on. You can't spend too much time. You can't spend all your time like straight reversing. You need hints. You need concrete data. Use a debugger. If you do have an entry point, like our exports, you could trace it. Or if you have the time, definitely you can go in here and start reversing. The only thing that bothers me are these jumps. So I need to find out these jumps. That's really important. I want to find out what that does. And the way that I'll probably do it is just to cheat. I'll probably open up Process Explorer. I'll find something that loads libcuda. Maybe when I write my first CUDA program, I'll just do a while loop. And I'll open that up in the debugger. I want to see if these are overwritten with something. See if these are trampolines that actually get rewritten. If they're not, because it makes no sense to do this, right? That's just slow. Unless something's going to actually use this trampoline, I don't see a reason to do it, but I'll probably use a debugger to fix that. I don't think that's an ioctl, but I'll keep it. So that's what we'll explore in the next episode. But I have some other cool stuff that I found. Let's see if anybody on Discord say anything. Like sweat balls in here. It sucks. What was I going to show? Oh, check this out. So people, I mentioned this last time, but GitHub is like, there's so many different types of hackers out there now. There's people that are just reversing these blobs and video BIOSes. I think they're trying to cheat or something at games, or maybe I don't know what they're doing, but they're certainly serious about it, and they're good. So I found some kind of good documents and good repositories for some cool stuff. There is NVIDIA does have a system management interface. If you've seen some of the Intel AMT bugs that have come out, Intel has a system management interface as well that has been giving up some really good bugs. It looks like NVIDIA has a similar concept. So this is in one of the SDKs I downloaded. I don't remember it, but you could search for just NVIDIA-SMI, and that could be cool to play with. You're going to probably use a combination of stuff. When you're looking at something this complex, you need to find things that allow you to query the hardware. You need to find things that allow you to upload, download from the hardware. You need things to debug. You need things to monitor, all these things. So we may use a bunch of different tools. And so this is all kind of going in my head and putting in the Discord channel. This could be I'll put this in the Discord channel because I think this is exactly what I'm looking at. Another target, so we could look at this. NVIDIA SMI. I don't know if you can actually debug from this. The other one is, I mentioned Process Hacker, but they did have a NVIDIA GPU plugin. So additional info here, just I think the way that he does it is he uses NVAPI to query some of the details. I don't think this has anything to do with CUDA. I think this is probably just what's used by any userland software to get detail out, because it tells you memory info, all those kind of things. I don't think it does anything beyond this. However, we might include some of this code in our in a proof of concept that I'll kind of build to get this data out. Video BIOS, all great information. Lots to learn, which is fun. We looked at this. Here's the best one. Okay, this is called NV Tools, and all it says is tools for people envious of NVIDIA's blob driver, and it's absolutely incredible the amount of work. So there's all these tools. Let me drop it into Discord. There's all these tools that you can actually look at the GPU. So there's some docs, which is fantastic. I think I actually have it up. Yeah, we'll look at this in a second. A disassembler for different instruction sets found on NVIDIA GPUs. Tools and libraries for database, decoding card description structures and video BIOS, writing directly to GPU registers, decoding encoding. I mean, what are they doing with this? But it's incredible. It was a good find. Let's just look at this real quick because he actually does have a little documentation. So all these different tools, I wonder if he talks to the NVAPI. French. Shout out to France. Congrats on the World Cup. Yeah, I'm definitely going to look at this. This is, I don't know if these are offsets into some kind of BIOS, but this is, he basically wrapped it, or she wrapped it in C, so that's pretty awesome. And here's a list of the tools. So tools to manually, let me zoom in. Tools to manually poke or query the card registers. We'll have to see if we can do this with limited access, so without admin. Although I don't mind using admin because, again, cloud. Easy for me to provision something with root. I think these have to run on Linux. But anyways, this is what's cool. Hardware destruction is likely possible. If I burn a card, that would be pretty fun. But look, we can write to memory mapped.io. We can peek and poke MMIO addresses. We can download the card's vBIOS. There's so much to just play with. Actually, the video RAM I can download. Man. Microcode, all kinds of cool stuff. Check it out. The docs are cool too, so it'll tell you, they've got schematics, they've got all kinds of things on the GPU. And the last thing I'll say before I let everybody go, NVIDIA does have some documentations on what they call Falcon, which is some microcontroller. I don't know if this is a microcontroller that works with the GPU and somehow manages some functions of the GPU. It could just be a generic microcontroller that they are building for stuff. It's called Falcon. I found it from this NV Tools repository, but it has, I haven't really read it. Again, I don't look at this stuff beforehand, and that's why I'm really unprepared. But you know, here's some architecture diagrams. So a lot of good info, a lot of things to learn, and tons of documentation. Okay, so I am choosing for right now CUDA. All the other things, anybody else look at it, we can all work on it together. I may go and look at them in different seasons if we're successful here on ZeroToZeroDay. But I'm going to look at CUDA, and between now and next time, I'm going to write my first CUDA program. I'm going to also write some proof of concepts that allow us to use some of these great projects to dump out strings and versions so that we can look at the versions that we have. And then I'll hopefully find out what this trampoline in IDA is and get us to the driver. I don't think it'll be fun to sit here, especially hour and then wait a week and do an hour to reverse too much. But I am going to find things that I want to reverse that are within a reasonable time period and reverse them live. So thanks everybody. I don't know if there's any questions on Discord. Nope. Appreciate it. I don't know if anybody is really how many people are watching, but this would be a fantastic project for multiple people to work on together. We've got Discord. Use it. I'll kick anybody out that's an ass, especially those bots that are trying to join. Anyways, I gotta go. It's hot as shit in here. But later, everybody. See ya.